We are from Alfred University. We had the district cup use case of the University of Central Florida. This year, we had our solar engineering design class work on it from the spring. Presenting today would be myself, Andrew Joyner, Charlie Murphy. Our advisors are shown below, as well as all of our group leads for each individual aspect of the project. First, we start with conceptual design and our sustainability goals. So the campus is focused on bringing sustainability to the university by focusing on the above 6 programs. Architectural consistency is aimed at proper lighting and ventilation should be ensured so that a sustainable environment is created and less energy is used. Already storm water is allowed to be saved within the university system, and the solar panels placed on the rooftops will be the best visual initiative for our design and goals that we aim to reach. So shown below are some of the equipment that we have decided as a class to what we are going to use. We have the LG Neon 2 solar panels, as well as the LG 400 A5 series. Due to the high power output, it has better performance on sunny days and double shielded cell structure, which is one of the most remarkable and adaptable modules available in the market, highlighting LG's cell technology and their monocrystalline N-type solar cells. The LG Neon 2 builds power yield, presently incorporates a 25-item and execution guarantee for better and unwavering quality. LG Neon 2 have been designed in light of feel utilizing more slender wires. This is our site plans, location, and layout. We have decided to go along with the rooftops, as well as we do show the land that was available to us through the competition. The University of Central Florida is bordered by Orange County on the east, west, and south sides, and the east side has low density residential, the west side has medium density residential, development, commercial, and office spaces as well, and the south is more industrial. The University of Central Florida is bordered by the Seminole Colony to the north. There are 3 future land uses bordering UFC immediately north of McCollin Road. Commercial, higher intensity planned development and planned development is going to be located there as well. So our hourly generation and details of input are shown here. Calculating hourly generation profile will require hourly profile solar irradiance, but that changes in milliseconds. So, which requires our irradiance data shown on the next slide. The NREL website is an incredibly useful resource as it offers the irradiance data of every location within the United States. Therefore, resources from the NREL will be used to solve these calculations. We have selected the area on average 5.58 kilowatt hour energy is available at this location for every square meter in the day. 743,000 kilowatt hour energy can be produced in 1 year, while saving will be about $76,223. The following image shows our irradiance model and is quantitative solution predicted the higher potential regions for solar extravagation. And the following numbers are what we were to come up with, as well as shown on what was on the previous slide. So next up is the distribution system impact analysis. And I'm going to turn this over to our classmate, Charlie Murphy.
All right, hello everyone. Okay, so we used OpenDSS. And this is a model of our grid system, and it's important to use for testing the electrical response. And that's why we modeled it in OpenDSS. We can get a graphical visual analysis of the issues with the system design. We can understand the power production, the power flow, voltages on specific elements based off the load shapes that we're able to extract, and that we were able to create using battery data or radiance data. It's relatively easy to change elements within the program to accommodate different designs by modeling the ways that money can be saved and mistakes can be avoided. And then the systems can be designed as well. So over on the right, you can see one of the charts that we generated in OpenDSS, and this was invaluable in creating our system design here. Okay, and then we have our system model that you can see over here. So our system model was determined that the most cost-effective solution was a PV-only system. Each of the locations of the panels were determined that they could be connected to the grid at that point. Irradiance data was used to model how much power the panels were capable of producing during different times of the day or the year. And those values were tested in the system containing all the elements to ensure that no component was strained too much. This was determined by overvoltage data, and most of the time, the system does not strain more than 5% from this determined value. All of these connections are run through one or two of the power substations, and the system was determined to be safer, modeled as such with the chosen solar panels. And then up next is our financial analysis. I believe Andrew wants to take over for this as well.
So what we did was we started out looking at only a panel installation system and began calculating the rate of returns and based off of zero storage capacity for batteries. And then we tried to expand that analysis to incorporate several different storage capacities, including 10% and 30%. So that we were not overwhelming our resources and that we were allowed to incorporate a small amount of viable options. So that was through the HeatSpring model within Excel. I modified it primarily to incorporate the cost analysis of the lifespan of the batteries to allow for an improved return and accuracy of the return rate. So for our storage capacities at 0%, the only positive return rate that we received was actually with zero storage capacity. So that is the design we decided to go with based on our financial analysis. Can you go to the next slide? So based on our PPA analysis, thank you. Can you go back 2 slides?
Yes, 1 second, sorry. Just I have to find the button.
So our PPA that we incorporated from the SAM software into the REOPT analysis was 14 cents per kilowatt hour. That was utilizing the generated model for the local utility to offset those purchases and to compare what the amount annually spent on financially just buying through a standard utility versus utilizing the PPA for a solar system. So we broke down the system costs into primarily construction, our developer margin that was provided, and any sort of structural modifications that were required to the buildings based on the building permits and other safety factors. We decided that the buildings were new enough and safe enough that those upgrades were not warranted. So that was actually decrease the cost of the system. So overall, we have some adjustments for processing and loan fees and certain things like that, where brokers get their amounts. So at the end of the day, we had roughly $11 million for aggregate project cost. So beginning within the project cash flow, at the very beginning of the project, while construction is ramping up, day one, you can see return from your panels that have been installed initially. But as you grow that system and you spend more in collecting materials that aren't yet installed, those costs are immediate. And so your net, your cash flow is quite negative the first year. However, at year two, you are beginning to receive resources back equivalent nearly to the amount you have put in. So overall, our customer savings over the lifespan of the project was forecasted roughly at $260,000 over a 20-year span.
So next up, we have our development plan. And our first slide is meeting with the district master plan. This was probably one of the biggest things our group wanted to follow. So we meet all the regulations and followed everything that the campus wanted to achieve. Our biggest development through the development plan and meeting with the district master plan was the storage energy through net metering. The excess energy is sent back into the utility provided. The power grid would then create credits and refunds, and without battery systems, that would be more expensive in the short term. Our next up is the applicable land use. We use the following land ordinances to select which areas following jurisdictional land use plans and regulations. We check the regulations on the site to select which sections would be able to be constructed on for environmental, historical, site constraints. We looked up the area on the website that was given from the Heat Springs website, and there was nothing that showed us on the website compared to other locations. We do not need to worry about shading, deforestation, and extra length of cable.
Jacqueline, we're kind of losing a little bit of that.
Can you hear me?
Can hear you.
So next up is our permits and codes. Very important things that we have to follow, including being in the state of Florida, hurricane dangers are a huge reality. And that was one of the biggest things that we needed to comply with that extreme weather and where it would be reasonable to build properties on. So thinking with the hurricane type weather, we thought that the pond location was not the best, nor was the tree location due to flooding and the cost of deforestation. Last up, we have our construction plan. We calculated over 10,000 modules will need to be mounted and installed. The mounts are $60 each, and the total cost of the mounts would be $600,041, $580 just to mount the panels themselves. And questions?